Alrighty, welcome everyone to day 25 of Advent Decode. Today is the final day of this. We are wrapping this up. Been a fantastic time doing this. I hope you guys have all enjoyed this. Thank you guys all for your support and all of this. It's been just incredible doing this. I'm so glad that I've gotten to day 25 this year and haven't stopped because they've been too hard. It's definitely come a long way in 1 year. So, at any rate, last day today. My normal videos will be resuming soon next week for the new year, so stick around there. If you guys have enjoyed, please sub to my channel. It's been an incredible time. Hope you've enjoyed, and thank you, Eric, as well, for putting these together. It's been an incredible year of doing these. I've enjoyed them very much, so thank you for all the hard work you put into these and for the time and effort that you do for putting these in and giving us this event we can do every year. So, at any rate, let's do this. Day 25, it is open. Let's do this. We finally reached the check-in desk. Unfortunately, the registration systems are currently offline and they cannot check you in. Noticing the look on your face, they quickly add that tech support is already on the way. They even created all the room keys this morning. You can take yours now and give them your room deposit once the registration comes back online. The room key is a small RFID card. Your room is on the 25th floor and the elevators are also temporarily out of service, so it takes a little while, or it takes a little energy you have left to even climb the stairs and navigate the halls. You finally reach the door of your room, so your card and beep. The lights turn red. Examine the card more closely, you discover their phone number for tech support. Hello, how can we help you today? You explain the situation. Well, it sounds like the card isn't sending the right command to unlock the door. If you go back to check-in desk, surely someone there can reset it for you. Still catching your breath, you describe your status to the elevator and the exact number of the stairs you should climb. I see. Well, you're the only option to reverse engineer the cryptographic handshake the card does with the door, and then inject your own command into the data stream. That's definitely impossible. You thank them for your time. Unfortunately for the door, you know a thing or two about cryptographic handshakes. The handshake used by the card the door involves an operation that transforms a subject number. To transform a subject number, start with the value 1, then a number of times called the loop size. Perform the following steps. Set the value to itself, multiply it by the subject number. Set the value to the remainder after dividing the value by that. The card always uses a specific secret loop size when it transforms a subject number. The door always uses a different secret loop. Okay. The card always uses a specific secret loop size when it transforms a subject number. The door always uses a different. Okay. The cryptographic handshake works like this. The card transfers a subject number of 7 according to the card's secret loop size. The result is called the card's public key. Okay. The door transforms a subject number of 7 according to the door's secret loop size. The result is called the door's public key. The card and door use the wireless RFID signal to transmit 2 public keys or puzzle inputs to the other device. Now the card has the door's public key and the door has the card's public key. Because you can eavesdrop the signal, you have both public keys, but neither device's loop size. The cards transform the subject number. Okay. If you can use the 2 public keys to determine each device's loop size, you will have enough information to calculate the secret encryption key that will unlock. For example, suppose you know that the card's public key is that. With a little trial and error, you can work out that the card's loop size must be 8 because the transferring of the initial subject, a number of 7 with a loop size of 8, produces that. Then suppose you know the door's public key, which is by the same process you can determine that the door's loop size is 11 because transforming the initial subject of 7 with a loop size of 11 produces K. So we're just gonna have to brute force. I mean, I guess we could brute force this. So which one's which? That's when you can use either device's loop size with the other device's public key to calculate the encryption key, transforming the subject's number of door's public key with a loop size of 8. The card's loop size produces an encryption key of that, transforming the subject number of what encryption key is the handshake trying to establish? So wait, which encryption key are we talking about here? The other device's public key to calculate the encryption key. They're transforming the subject number of blank the door's public key with a loop size of 8 produces the encryption key. Oh, so we need the door's public key. Which one's which though? I'm guessing it's gonna be card and then door. Okay, so we have the first. Let's first get the loop sizes. So we have the door. Okay, so what we need to do is we need to create a method here that's going to be public and get loop size. It's going to take in the int public key here, and what we're going to do is we're going to have to do while boolean found equals 0, or boolean found is false. So while not found. Okay, so we're going to do this for each different loop size. So the card's public key is that. So try you can work out that the card's loop size of 8 because of normal transforming the subject of 7. So is it always 7? So the card transforms the subject number of 7 according to the card's secret loop size. So it's always going to be 7? The number of times is... Oh. Wait. The handshake used by the card and door involves an operation that transforms a subject number. Transform a subject number, start with a number value 1, the number of times called the loop size, perform... Oh. Okay, so we're going to need to do int subject num. Wait, this is the loop size. So are we just going with it's always 7? Okay, so we're gonna have to do loop size. Well, we only need to do loop size once. Because if this is right, it's going to be while, so we're gonna have int num. I'll just call it num. We'll set this equal to 7 to start. And we're gonna do while num does not equal public key, continue going on. We're going to need to do int loop size is 0 to start. Loop size plus plus, and then we're going to need to then do num equals what? Set the value to itself multiplied by the subject number. Obviously, I guess we also need then the subject number. So this will be sub number. So it's going to be equal to number times sub number, and then remainder of that. So we're just going to do system out print line of get loop size, input strings, get 0, parse it to an integer. So do the, oh, this needs to then return loop size. Okay. So does this give me an answer? It does. It's a really high loop number. If I put in, so will this give me 8 if I put this in here? It gives me 7. Well, are you gonna be off by 1 again? I guess a 1 is just initial. Okay, so then it's gonna be that. So then we have the loop size of that. So we just need to do this for both of them. Yeah, okay. So you can count the encryption. You transfer in the subject number of the door's public key with a loop size of 8. The card's loop size reduces encryption. So then we need to take the door, which is going to be the second one. We need to take that one, throw that through. Okay. All right. So what we can do is we can do int card essence. No. We want to do int card pub key is going to equal that, and then we need to have int door pub key equals that, and then we want to use this. Actually, not use that. We're going to do a for loop here for int I. Actually, no. Card So doors public key is, okay, so then transform the subject number of the doors public key. So we do need the doors public key. Okay, so we need to do int door pub key. So these are wrong. That's the doors public key. This is actually the card's loop size. Sorry. This is then the doors loop size. Okay, we put that in there. And then we do for I equals 0 while I is less than. The doors will be loop size of 8, the card's loop size I plus plus. Okay. Encryption key of. So we should get the same encryption key. So I mean, in theory, this is kind of whatever. So we just do the same exact thing. Or we then do int encryption key 1 is going to equal okay, so there's the door, here is the card. So it's going to, so the encryption key 1 is if we take the doors. So in theory, we don't need to do both of them, but we're going to just to verify. So we take the doors public key, and so we do that. Wait, num sub num. Oh, take the encryption. Sorry, encryption key, door public key. Okay, and so that'll give us that. Then we can do this one more time. But this time, it's going to be on the card's public key. And it's going to be for the door loop size, and then it's going to be then encryption key 2. And so in theory, when we get to here, we should be able to do system out print line of both encryption key 1 and encryption key 2. We should get the same numbers, shouldn't we? And we don't. I wonder if these are longs. These probably need to be longs. Maybe. Or not. So we put this in for the doors public key. And we put this in for the card's public key. We don't get the same. We don't get the right answer? No, we do not get the right answer here. Okay, let me output. Let's do a system out here of the loop sizes. So it's gonna be card followed by door. We get 11 for the card. That's backwards. Oh, because these are backwards. Okay, so those are right. So then it's just then our little loop here is wrong. Should we starting at 1? Ah, we were just, okay, because we have the first loop is the outside, right. I guess we could just start these at 1. So I guess those should be started at 1. Then we can do this. And now it should give us the same answer. Okay, that's why I was messing up. Alright, so we can get 14, same thing. Sweet, there we go. Okay, so now we can reset this back to our input. And now we should get the right answer. Hey, look at that. And we can put this as the encryption key. Hey, we got our gold star. Alright, part 2. Turn the light turns green and the door unlocks. You collapse onto the bed in your room. The paper goes off. It's an emergency. The elf calling you explains the self-serve machine, the cafeteria, and Subbasement 7 just failed, and you're the only one that knows how to fix it. We've already dispatched a reindeer to location. You hear the sound of hose on your balcony. Reindeer carefully explores the contents of your room while you figure out you're going to have to pay 50 stars you owe to the resort before you leave. Noticing you look concerned, the reindeer wanders over to you. Sorry for your trouble. Note that I know the pouch reads, see in the bottom, the gold coin, the little picture. Oh. I don't have enough stars. Unfortunately, I can't do this last one because I didn't complete Day 19 or 20, part 2. Oh. Well, that's awkward. 1 second. Let me check into those real quick. Ah, yes. I remember 1920B I couldn't do. 19 was because of the parsing tree. I couldn't figure out how to get the B and F working for that. And day 20 was the one with the tile puzzles. I mean, I can't just like complete those in like 10 minutes like I would want to. So, yeah. So I guess that's gonna do it for me for this year. I can't actually do kind of beyond figuring someone else's code out and doing that way. Well, that's kind of anticlimactic. I can't do. I can't do it. Yeah, I'm one of the people that are stuck because I didn't get all the stars for the days, so I can't actually go back and complete these ones. Oh. Well, this is awkward. Well, unfortunately, I think this year's Advent Code comes down to a little bit of anticlimactic ending because I can't do part 2 because I'm missing 2 stars. So, well, anyways, yeah, I guess that does it for me then. Well, if you guys enjoyed, like I said, my content that I normally do will be back in the new year. So hopefully, guys, if you aren't subbed, please do so. It helps me out a lot. Very appreciate it a lot. It's been a fantastic first year of doing YouTube more consistently. But yeah, again, Eric, thank you very, very much for doing this. Appreciate it, man. If you were watching this, I love it. It was very much fun. I'll probably go back at some point and do these last 2 to get the all-stars this year. But at any rate, there we go. Advent Code 2020 is complete for me, minus 3 stars, 2 puzzles. Yeah, it's a huge improvement over last year's. I mean, what I even get for last year? Let's go to 2019. Over last year's 35 stars. So there we go. Anyways, hope you guys enjoyed. Thank you guys for watching. I'll see you guys all next time. Peace out.